Hello and welcome back to Mission Control Houston. Again, we have a special guest today at the Public Affairs Console. That's Scott Stover, the lead flight director for this Expedition 30 increment or expedition. Welcome to our console, Scott.
Well, thank you very much. Always a good time to be in mission control and able to talk to folks around the world.
We always love being here too. Let's start our interview off with a little bit of background about you, where you're from, and what kind of education you have, and what it took you to get to here.
Sure. I grew up in a small rural town in Pennsylvania called Leymasters. It's about 45 minutes west of Gettysburg for anybody who wants to try to find it on a map. But with that, I again, a small rural town. My father was a firefighter, my mother a nurse. I was an only child. From there, I went to Penn State University and got a bachelor's degree in aerospace engineering. From there, I always wanted to work at NASA, work in the aerospace industry, and work with astronauts and going into space. So that's something I always went after. As I said, I graduated from Penn State with an aerospace engineering degree, and I came to work for a contractor here in Houston called United Space Alliance, where a lot of the folks that work in operations work for that contractor. I worked there for about 5 years, and along with that, I pursued a master's degree at the University of Houston. I got one of the very first Masters of Science in Space Architecture. It's a one-of-a-kind degree that right now the University of Houston offers, and I myself and a few of my colleagues actually championed that degree and created it. So we're able to get that degree underway. I graduated there and was able to then continue working for USA as a flight controller here in Mission Control Houston, working with the electrical power system of the International Space Station. I worked there for a few years and was able to do what we call a badge swap, come over to the actually working for NASA itself. I continued doing the same exact job as a flight controller with the electrical power system of the space station. And a few years later, I was able to become what we call the group lead over those flight controllers. For that person has more of the job of making sure that the correct folks are being trained to be flight controllers, work out the schedules, who's on console, who's supporting our simulations, and who's assigned to work the big assembly missions that were going on at the time, and those type things. A few years later, I applied and was accepted into the flight director office. So I've been a flight director since 2009, and this is my first increment as a lead flight director. I was able to work at least one of the shuttle missions. I worked STS-132 as a flight director, and that was a very exciting time again, watching the end of the shuttle program, but finishing up the actual construction of the International Space Station was a great time to be a flight director, and seeing all the work that was going into the culmination of the Space Shuttle program.
Wow, that's a really varied and interesting background, Scott. Thanks. Well, before we get into the details of what a lead flight director does, can you give us a little bit of background on what a flight director does in the International Space Station control room, especially during these days when assembly is virtually complete and we're in the operations mode, really focusing on using this unique laboratory we've put in orbit?
Sure. Of course, the flight director here in Houston is the person in charge of everything. So we manage the day in and day out operations of the space station. Of course, we work with our international partners in Moscow, in Scuba, in Munich, the folks in Montreal, and we also work with folks in POIC, which is in Huntsville, Alabama, which manage our NASA payloads for us. The important job of the flight director, and of course everybody that sits in Mission Control Houston or any of the other control centers, is first of all the safety of the crew. We monitor all the activities that are going on and the operations of the vehicle systems to make sure the crew is safe, and that the whatever operation we're doing that day is going to safe and continue the operation of the vehicle for the foreseeable future. We manage the timeline and make sure that if items in the timeline are taking longer, we actively prioritize the upcoming events. Is the activity that we're doing that is taking longer more important than an upcoming activity, or do we want to find a stopping point in what we're currently doing and proceed with another activity that we deem a higher priority? So again, the main thing is we're managing the safety of the crew and the vehicle and following a timeline and laying out what needs to be done to keep the vehicle operating, and of course do the all-important science, which is what we're really trying to get accomplished on board.
Okay. And then so that's the general flight director duties, and that's anybody that sits in your chair for a shift that usually lasts about 9, but on the weekends 12 hours. What about for an increment or expedition lead? How does that differ from the day-to-day flight director job?
It's actually very different. So I come in every morning and we have reporting meetings out to both my management, also to program management, reporting what happened over the previous 24 hours, and then looking ahead of what the plans are for the upcoming days. Once we're sure the management's happy of where we're at and where we're going, my job is to focus usually at least 1 week, maybe 2 or 3 weeks out into the future and plan those priorities that the program has given us out over those next 3 weeks, verifying that we can accomplish the priorities that the program has given us to do. So I spend most of my time thinking a few days in the future. You'll see me in the hallway, and I don't even know what day it is today because I'm thinking 2 or 3 weeks into the future. And it's the job of the flight directors on console right now to execute the plan that we've put together, and they'll tell me how things went today and if we need to replan anything. So again, I'm looking more into the future and what's going on, in managing a team of flight controllers that aren't sitting in the flight control room but are helping me with that plan, getting that plan pulled together, and looking again long term of where we need to be throughout the 6 months of an increment or an expedition.
Now, a good example of that is you were in the International Space Station Mission Management team this morning, I know because I heard you. What can you tell us about what you briefed the program managers around the world about what we're doing on orbit today?
Sure. So this morning I went through the activities of yesterday, in which luckily there were no problems from yesterday. Everything went well. We performed overnight. We performed some robotics operations to take images between modules to verify that we understand our computer-aided design models are correct of how the space station is actually assembled on orbit. So that's what we did last night. Again, today, as I'm sure folks have seen already, we're focusing a lot on the cabin fan assembly in the Columbus module and making sure that it's clean and ready for continued operations. We're going to continue that tomorrow. So a lot of my briefing this morning to the mission management team was about what happened yesterday and then giving them a preview of what we're doing today.
And I would imagine the ventilation would be an important item of the architecture for you.
Yes. As a space architect background, ventilation is a very interesting part of the space station. Each of the modules, of course, were designed and built in a computer on the ground, but were never actually linked up until they got into orbit. So understanding the airflow between the different modules of the International Space Station, from the Russian segment through the U.S. modules, the JAXA module, and the ESA module, is a very complex airflow system, and we need to make sure that we're keeping it cleaned and well ventilated. Of course, here on the ground, you don't have to worry too much about your exhaling CO2 or anything like that because we have natural convection due to gravity that will pull the CO2 away from you and provide you with fresh oxygen. That's not true on orbit. If a crew member is in stale air, the CO2 that they exhale will just stay in front of their face and can actually asphyxiate them over time. So we need to make sure that the air is constantly moving on orbit, and therefore providing the crew with fresh, clean air. And that's why we investigate our ducting and our fans to make sure that we're providing that clean air throughout the vehicle.
And we do a lot of recycling of the atmosphere on board too, right?
Correct. We've got trace contaminant control systems, which clean harmful contaminants that may be either off gas from new hardware or from a payload that will, give off some kind of gas. Then we also have our carbon dioxide removal assemblies, which specifically go after the CO2 that's being exhaled by the crew members. And what that does is that absorbs that, and then we are able to vent that overboard. Or sometimes we have a processor called a Sabatier engine, which takes that carbon dioxide and actually can transform it back into water for us. So it's a very regenerative system, and we try not to waste any gas or any water that we can.
Great. And then another part of your job is planning for the expedition before it ever begins. And this crew has had some changes in the duration of its expedition. They got off the ground a little bit late because of some issues with one of the Russian launch vehicles. But we maintained the crew on board the space station consistently. We've done that for 11 years now. And now we're hearing that we're going to adjust the flight program a little bit more so that this crew actually is going to get their full planned stay on orbit. Can you tell us a little bit how that all goes?
Sure. So we were delayed due to an issue with what we call 44 progress. The 44th progress to the vehicle was actually lost on launch, and therefore there was a lot of concern over the launch vehicle, making sure it was safe before we put human beings back on it. So there was a lot of investigation that both our Russian colleagues helped out with. Of course, they led the actual investigation, and we just sort of monitored and made sure we understood the progress they were making with that investigation. Once it was determined that the vehicle was safe and we were ready to launch the crew, that happened back in November. We were able to launch 28S, which Mr. Burbank and his crew members flew on. Before that, I was actually part of the team that did a lot of the investigation. What would we need to do if we decrewed the vehicle? If we actually brought all the crew members home, how did we need to configure the vehicle so that it'd be safe and ready for a crew to return once we were ready for that? So that spent a lot of time leading up to the increment. But we also spent a lot of time making sure that Dan and his crew members would have the right amount of handover available so that in the short period of time that they were going to be there with Mike Fossum and his crew, they would be ready to take over and be in charge of the vehicle. Um, Now that said, we have now extended our mission here at the end. We originally were supposed to have 28S return in the middle of the middle of March, and is now coming back at the very end of April. So that's about a 6 weeks extension. And what we've done is I've worked with my upcoming increment lead flight director, Matt Abbott, who's the increment 31 lead, and they had already started laying out plans for what April was supposed to look like, what May is supposed to look like, and we have started taking what their plans were and adjusting them to the crew members that we'll have on board so that we can follow those priorities and continue doing valuable science and work on board while we wait for 28S to come home and then eventually the launch of 30S in May.
And so, to wrap up the interview today, you just finished up with talking about science. How much science is the crew actually getting accomplished on board the space station?
So science is a very hard thing to put a number on. What we do is we look at how many payload operations that we have planned, and that can be anything from the crew members, working with the combustion integration rack, which I think folks have seen today. We've also have multiple fluid experiments. Capillary flow is one of the things that we were very interested in, and of course the crew members themselves are guinea pigs. We do all kinds of science studies on the crew members themselves of their food intake and their bone loss or anything like that. So when we're trying to figure out how much they've actually done, we calculate all those things that we put on the plan and we come up with a number of hours. So right now, the goal of the program is to do about 35 hours a week of payload operations. Due to some of the extenuating circumstances of folks being delayed getting on orbit and things like that, we've actually upped that number to make sure that we meet that average. So we're doing about 50 hours a week of crew-tended payloads. That doesn't count all of the ground-tended payloads that we're also doing. So you have the alpha magnetic spectrometer and a bunch of payloads that don't require 24-hour crew interaction. And so those are continuously running, gathering science data and bringing that down all the time. So that's even beyond that quote-unquote 50 hours a week that we're doing.
Okay, well, Scott, thanks a whole lot for being with us here today. And just to look ahead at tomorrow, we're going to have Tara Rutley from the International Space Station Program Science Office talking to some more about the research on board the station with us. And then on Friday, we're planning on having Trent Martin from the AMS project, so he can talk a little bit about the cosmic ray collection that they're doing. So with that, we'll say thanks again to Scott Stover, the lead flight director for Expedition 30 and this increment aboard the International Space Station. Thanks so much, Scott.
Thank you.